Hello everyone. Let's understand another question we have is Q3. So it is a minimum sum after divisible sum deletions. Okay, means we have to do what? We have to find the minimum sum after what? Divisible the sum deletions. Okay, let's understand how what the question is saying that. Very first, you can repeatedly delete any contiguous subarray whose sum is divisible by k. That is why it is saying the deletion. Okay, so our goal is to minimize the final sum of the remaining elements, right? What we can do, we can delete many times as we want, right? But if we find any continuous array whose sum is divisible by the k, so you may repeatedly choose any continuous array whose sum is divisible by k, just delete it. Okay, that is why it is saying deletions. So after each deletion, means after delete operations, the remaining element will be there, right? Then we have to take the minimum possible sum after doing all these operations. Let's understand for this example. So example 1 we have given, as you can see, we have given triple 1 and k is equal to 2. Means total, if you see, is 3. So you can delete a subarray of sum equal to 2 because there is 2 ones is there, right? Can we say that? So max deletable is equal to 2. What is the leftover? 3 minus 2 is equal to 1. Can we say that? So that is why it is saying that delete the subarray from 0 to 1 is 1 1. So sum is 2, which is divisible by 2, correct? And that is why we are leaving only one element here and the remaining is here. Let's understand example 2. Here in example 2, we have given these elements and k equal to 3. So if you do the sum, 3 1 and 4 8 and 1 is 9 and 5. Okay, so total is 14, correct? The target is to delete as much as possible in the chunks. What are the chunks is there? Which is divisible by what? If their sum are divisible by 3. So the optimal answer when we do the deletion sums to, let's call 9 for here, right? We'll say the leftover is total 14 and we'll do minus 9, right? So total become how many? The leftover is a 5. Leftover is 5. Okay, I hope you understand. So very first, what we should do, we should use a kind of prefix sum, right? So for each element, we'll do the sum of ith element, right? And we'll find the some value, right? Let's suppose call the possible value, right? Let me tell you how. So let's suppose we are talking about this one. So if you use this prefix sum, right? If you'll take a let's suppose we have some values are there. Let me write it here. Index I is we have 0, 1, 2, 3, 4 and 5. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Okay. So we'll go till 5, let's suppose. Okay. So nums at, if you do the prefix sum, remember I minus 1 will do. Okay. What is the previous element at here? Nothing, because we don't have minus 1, right? At 0 we don't have a minus 1 index, so we'll say nothing. What we have at 1? We have 3. At 2 what we have is 1. Similarly we have at 4, 3 is 4 and 1 we have is 4 at 1 we have and 5 is 5. So these are the elements we have given. So if we'll take P0, okay, prefix sum. What is the prefix sum we'll call? From here it is nothing but the 0. If you do the prefix sum from here, let's call this is 3 and prefix nothing but 0. 0 plus 3 is 3. Now 3 is prefix, now 1 is current one, so we'll get 4. Like that, if you'll update 1 plus 4 plus this 4 is 8, then it will become what? 8 plus 1 is 9 and 9 plus 5 is 14. We got it, right? So we find the prefix sum. Let's understand if we have the array. So we'll find the remainder at each index. Let's call not these are the ith index. So remainder at I. What we'll call at 0. So how we are going to find the remainder? Remainder will find like we have the prefix sum at I, right? And we'll do mod k, right? The remainder, whatever the remainder will come, right? So if we'll do, we'll get the remainder. Let's call, in this case it is 0, right? We know a we have given is 3. So 3 by 3 is nothing but 0. Divisible is 0. Now here it will come 1, here it will come 2, here it will come what? 0, because 3 by 3, it will be divisible by 3. 14 it will get 2, right? Like that we will get. Now what you need to do, you will create, let me remove from here right now. I hope you understand this one. Now think, we'll create a DP. You know the dynamic programming, right? DP will take and will say what is the max deleted up to I. So this is your max deleted up to I. What is deleted? So DP at 0 we have not deleted anything, correct? DP at 1 we can delete 3, but say delete 0 0, delete 0 0. Can we say that? We can say that. Now DP at 1 happened, DP at 2 will is nothing but 3. So no delete, no deletion, no new is there, right? Now DP at 3 will say equal to 3, no new is there. Let's suppose DP at 4 will get what? We have the 9, right? So this is the best candidate, right? Because at here, how many we will delete? So in the delete will have two things, 0 and 3. Can we say that because best at 0 plus prefix at 4, right? We have seen, we will delete it, right? So we'll say prefix at 4, we are able to delete it, right? And so we'll say best at 0, and then we'll say 0 plus 9, we'll say total will get here, okay? Similarly, we'll find DP at 5, and so the best candidate is 2, right? And we'll say DP at 5, we'll take DP at 5 here, 14, and we'll say total is 3 and 4 will do plus the earlier deletions. So now you have to find the what is the best I was talking about. The best is, we'll find what initially will take means after processing the index, what is the remaining is there, remaining index. So we'll say that some value will be there, 0, we'll say infinity, infinity, like that. We'll keep updating here. When we reach here, we'll say okay, the remaining is 0, -1 and -5. Like that we'll keep going here, right? Here infinity will become -1, 0, -1 and infinity. I'll explain you when we write the code, okay? When we talk here, it will become what? 0, -1 and -5. Similarly, best will become 0, -1 and -5, like that. We'll keep digging like that, and you will find the prefix sum will work. So when we are I at what you call 1, right? We can delete 0 0, right? And so because it is divisible, when we reach I equal to 4, we got 9, so we can delete this. So candidate for the best is what? We can 0 plus 9 is 9, we have seen, right? And that's corresponding the deletion of single array 0 and 3, right? So we'll say 0 and 3, that is fine. What it gives you the sum? Subarray from 0 to 3, it will give you the sum of 9, and so the best candidate is subarray is 0 from 0 to 3, 0 to 3, that will give you the sum is 9. So we'll start from here to, we'll go here, and we'll get the sum is 9. Understand? Now talk about when we reach at I equal to 5. So we can also get DP at 5 equal to 9, right? By taking two things. We'll take best 2, right, here, and I forget that we are talking about yeah. So we had what? -5 we have, and 14, right? Yeah, it is giving 9, right? Means this is the, if you'll talk, this is your best 5, best 2, and this is your prefix at 5. If you'll do the sum, you will get 9, right? That is also corresponding to the deletion. So we'll say from 3 to 4, the index 3 to 4, it will give you the sum 6, right? So what we will do, we'll do the deletion and we'll keep checking all the time this value, and we'll decompose from 0 to 3 4 like that we'll do, and we'll keep checking that the value is coming 9. Yeah, it's coming 9. So both are valid ways to delete the 9. Okay, like that we will create. Let's understand how I have written the code. So very first you will define these required things, right? The n, you will find the n, then the total you have to take in the long because we have to do the mod. Okay, then for all the value you will find your total, right? Then you will define the prefix and the prefix and the prefix. Okay, so we can delete the element. So we'll take the for the best we have to define the negative infinity, right? So we'll take the best that we are talking about, we'll fill with the infinity. So we know that the states are, we have the prefix, initial state is prefix at 0, remainder will be 0, and if you'll find the dp at 0 minus prefix at 0, we'll get the 0. Will best will also initialize from 0. So each time you will find the prefix, right? Prefix, you know how to find the prefix sum. So we'll find the prefix, we'll check, you will take the you take the divisibility. If it is divisibility is coming, right, r. So if r is less than 0, we'll update our r plus equal to k. We have to make the shift. Then you will find dp at I, you will find the dp previous, right? How, what you need to do, you will take the interval like this. Okay, and then we need to find the best value, right? So for take the same remainder, you will use best at r plus p at I. Okay, means prefix at I. If it is not negative, means we will find the best candidate using this one. If it is candidate is greater than the dp at I, we'll update our dp at I. Otherwise we'll update the best for the remainder, right? And then you will check the condition. If condition is it is best, right, you will update the best at r. So you know your best, that is -5, right? Then dp at prefix, you will update it dpi, right? Dp at I, and each time you have to update the value. So you'll say max deleted is the dp prefix value, right? And then we'll initially we have all this value, so we'll the total value we have already calculated, or the max deleted you will do, so it will give you the remaining element sum. Okay, so that's all I have in this video. If you have any doubt, let me know in the comment section, guys. So I'll do the deep dive session, don't worry. So this is for the contest problem, so it's still you have 12 minutes, you can write the code, and I'll let me know in the comment section you are won the code, then I'll put in the comment section. Thank you for watching this video. I'll see you in the next one.